Okay, let's look at our first example. It says use the Rostrum method to represent the set of the days in the week. So this is where I'd have the students write the set of the days of the week. And then I would have them do it, and I'd have them try it, and I would see what they did. And I would start something pretty crazy, like I would start on something like this. I'm going to start on Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and Monday. Now, why did I start on Tuesday? I started on Tuesday to prove a point. The point being that order does not matter. Almost every student would either start on Sunday or Monday. But what I want you to realize is they're the exact same set. No matter what you started on, you should have each one of those 7 days and only those 7 days written out there. Don't get lazy. Don't use abbreviations. So don't just write like WED period, right? Write the full word. Take the time and do it properly. Order doesn't matter when it's something ambiguous like days of the week. Only order matters when it's letters and numbers. Okay? So it says use the roster method to represent the sets of month that start with the letter A. I love sitting here teaching this because I sit here and watch and I can see them visually going through their mind. January, February, March, April, May, June, July, August, September, October, November, December, and I can physically see them searching through their mind, going through the list like that to determine which months start with the letter A. Again, here order doesn't matter because it's ambiguous. It's a name of a month. But in the next example, order will matter, not necessarily the next example, but in some examples, order will matter again when it's numbers and letters. Okay, here. So it says write a word description for the following set. Again, here I interact with my class and I ask what they would say, and a lot of people would say the alphabet. Okay? Well, first of all, it's a set, so we need to write the set of. Everyone's sentences should start with the set of. Anytime you see those braces there, if you see those braces there, you need to say the set of. Okay? So it's the set of what? And so people would say the set of alphabet. Well, that doesn't make sense. That's not an English sentence, right? So then they would say the set of letters in the alphabet. And I'm like, that's great. And I like that. And I would accept that on the test if you said the set of letters of the alphabet. But I push you to go even further. Okay, we have a warped point of view that this is the only alphabet. I ask you to think of a world point of view here. Is this the only alphabet? And the answer is no, it's not at all. So if we wanted to describe this the best way possible, I would say the set of letters. One sec, let me get my pen. I would say the set of letters in the English alphabet. That's what I would say if I was trying to get a better verbal description of this one. Okay? Now it says, write a word description for the set March and May. Well, it seems to me that those are, months? So can't we use example 2 as a nice little kind of idea of how we should do this? First of all, it's a set of, because we have the purple, right? So it's the set of. How about months that start with the letter M? Okay, that would be a nice one for you right there. All right. Okay, so now we need to learn our numbers. So I'm going to draw you some pictures to help you with the number system here. Make sure that you understand the number system, but you do need to know this. You don't need to know, like if I say define the whole numbers, you wouldn't have to define it. But if I say what whole numbers, you need to know what numbers I'm talking about. So let's make sure we know the number systems. So what does the number system start off with? It starts off with what's called the natural numbers, which are going to be represented with the script N, or just an N. You can just write a normal N. That's the natural numbers. And these are the numbers where you learned how to count. Well, you learned how to count, most likely as a baby or as a young child, using your fingers. And you always start with the number 1. A child doesn't understand the concept of 0. That's something that they learn a little bit later. They always start with the number 1. So you start with the natural numbers, which is the numbers 1 on up. You move on to what's called the whole numbers. The whole numbers are all of the natural numbers. So 1 on up, the only thing it adds is that concept of 0. What if you have nothing? Okay? We move on from there, and we would go on to the integers. In the integers, what the integers add on is the negative numbers. Okay? Integers add on negative numbers. So you have all the positive numbers is the natural numbers. Adding 0 makes it the whole numbers, and adding the negative numbers makes it an integer. So I want you to think about here. Let's just pick a random number. How about the number 2? And I'd ask, is the number 2 a natural number? Well, of course it is. Well, is the number 2 a whole number? Yes, it is. Is the number 2 an integer? Yes, it is also an integer. So that's how this picture works. If you know Venn diagrams, that's essentially what we're doing is a Venn diagram. Okay? So, is the number negative 2 an integer? Yes. Is it a whole number? No. And is it a natural number? No. So natural numbers, 1 on up. Whole numbers include 0, integers, positives, and negatives. Okay? We move on to the next set. What's the next set called? Well, the next set is called rational numbers. What is a rational number? A rational number is any number that can be represented as a fraction. A rational number is any number that can be represented as a fraction. So I'm just going to write fractions. I'm going to give you some examples of rational numbers. 3/4 is a rational number. But I also want you to realize 2 is a rational number. Why is 2 a rational number? The question becomes, can it be written as a fraction? And the answer is yes. If we write 2 over 1 as a fraction, that is equivalent mathematically to the number 2. So if the number can be written as a fraction, it is called a rational number. Of course, this includes negative numbers as well, so I'll just put something like negative 5/3 is also a rational number. Okay? It has positives and negative fractions. Well, that's not all the numbers that there are. There are other types of numbers. What are the other types of numbers? The other types of numbers are called irrational. And what are irrational numbers? Those are numbers that cannot be written as a fraction. If a rational number is all numbers that can be written as a fraction, irrational numbers are all numbers that cannot be written as a fraction. What's an example of an irrational number? Square root of 2. Square root of 2 is 1.14, and it goes on forever, right? So it's a non-repeating decimal that goes on forever. How about pi? Pi is another number that you see when you deal with circles, which we will have seen in the geometry section as well. Pi most certainly is a value, a number, but it cannot be written as a fraction. It's 3.141598, blah, 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 and it goes on forever. Never repeats, never finishes. E is a nice irrational number. There's infinite number of rational numbers, numbers that cannot be written as a fraction. That's what irrational numbers are, okay? And then what happens? Put all of those numbers together, and those are called real numbers here, okay? So, N is for natural numbers. If you see a script W, that's what you use for whole numbers. Integers, in this book, they use an I. I'm not too fond of that. Really what integers are is a script Z. Not that you need to know these, but if you use these, I will accept it on the test. Rational numbers are usually a Q, a script Q, and that stands for quotient. Okay? Irrational numbers is usually the I, and then the real numbers is where the script R comes in. All right? So, every natural number is a whole number, every whole number is an integer, every integer is a rational number, every rational number is a real number. Irrational numbers are their own beast. They're still real, but they are not written as fractions, so they're not anything else. So you need to have this picture in your mind. It's very, very important, because what if I said, what are the natural numbers less than 4? I want you to think of the natural numbers less than 4. If that were a question on the test, you would have to know that the natural numbers start at the number 1. So the answer to the question would be the set of 1, 2, 3. That would be the natural numbers less than 4. Versus that same question, let's think about it. What if I said, what's the whole numbers less than 4? Well, if you don't know what the whole numbers are, you might not know that it includes the number 0. So it would be the set of 0, 1, 2, 3. So just knowing the definition for whole numbers and natural numbers, that natural numbers do not contain 0, while whole numbers do, the answer to that problem changes greatly. So know the definition in the sense that you need to know what numbers we're talking about, because in the problems in words, I will say, what are the natural numbers, or what are the whole numbers, or what are the integers that blah, 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 blah. And you'll have to understand those sets. Okay, last thing on this page is about, let's read it. It says the set of natural numbers is also called the set of counting numbers. So if it says counting numbers, those are natural numbers. It says the 3 dots, if you see 3 dots like this, those are called ellipses. And they indicate that elements of a set continue in a manner suggested by the elements that are listed. I want to write a little note here, really important note. The note's going to say, you must have 3 items before an ellipses. So what am I talking about? Well, if I have a set and I say 1, comma, dot, 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 what comes next? And the answer is, I have no friggin' clue. What if I wrote the set 1, comma, 2, comma, dot, dot, dot? I would say, what comes next? Well, some of you would assume the answer is 3. But couldn't the answer be 4 as well? Couldn't I be doubling every single time? So 2 items is not enough to establish a pattern. However, if you have 3 items, 1, 2, 3, now it should be clear the next item should be 4. So if you ever want to use ellipses, you are supposed to have 3 items before you use ellipses to establish the pattern. And if you'll notice, every time they do a minimum of 3 items, looks like sometimes they do up to 5 or 6 items before the ellipses. I'm just saying you have to have a bare minimum of 3.